Okay. So, hello Zurich, good afternoon. My name is Stefan Arizona here in Singapore. I'm replacing Gerhard Schmidt for today's lecture. He's in Bali in his holidays. And so I'm doing this sort of remote teaching the first time, and I hope I won't get confused here with the slides and the Tamberg and all that. As always, please just interrupt me when you have questions. Remember that there's like 1 or 2 seconds of delay, so this might take some time. So before I proceed, is the audio quality all fine? Can you hear me?
Yes.
Yes.
All good. All right. So just as a brief overview, Anastasia, I'm not sure this is what I found. Yeah, the excursion to Bibliotheca Werner Röxlin is scheduled for November 7th, yeah?
Yeah. But I will send an email, like a reminder and with all the details.
Okay. So I just thought I put that up here already early so you all know. That's where it's going to go, and for all further questions, Anastasia will be available for you.
More information will come on the lecture just before this trip, so I will provide you more information on that.
All right. So, as a brief overview, what's going to happen today? I got quite a whole bunch of slides, so I'm not sure if I can get through all of it. We will do a brief review of Lecture 1 of the tutorial lecture you had by Professor Schmidt. Then we will have a look at different types of information architecture, and then also put this into context with the whole evolution of computing and even a bit earlier librarians, library organization. Then we will have a bit more depth insight into the social media, which is a very important topic at the moment and also quite important in relation to information architecture. Then a few questions, what might be the next few trends, or basically I will tell you that it's very hard to say at this point what the future trends could be. And then I will also give some relation, which is basically my core topic. I'm a software engineer and a software architect, and I will also highlight a few areas that are related between information architecture, software architecture, and also hardware architecture. Okay, let's briefly go into a review of Lecture 1. You have learned that architecture of information basically expands the definition of architecture to areas outside the traditional realm. That means that we use architectural metaphors to better structure, understand, and communicate information. So examples there are information territory, information spaces, as I just said, computer architectures, hardware, software, and also network topologies, network architecture. If you look at the term information architecture, we can have a look at this from 2 sides. We can put the focus on information, and there we mean the metaphors and principles of physical architecture that are applied to digital data and information to create an architecture of information and using information as raw materials. The second point is when we put the focus more on architecture is that making the invisible visible in the form of digital information that is applied to physical structure in order to better understand and design physical architecture. You probably remember some of the projections that have been on some of the buildings and at Science City using sensors and putting images up to facades, for instance. Okay, so this is as a very brief review of what happened, I believe, during the first session. Last time was a bit different when Daniel Aliaga was there. So I would jump into our first topic to give you an overview of different information architecture types. So you probably also already have heard a few details of that, but then if it's a repetition, then it's fine as well. So very roughly we can divide or list the different information architecture types as space, structure, and interface. So there's 3 images given as an exemplary illustration. On the very left you see the library Werner Oechslin in Einsiedeln, which is a very typical space of information architecture because it contains a lot of information, namely the books. Yeah. So other examples would be labs, information points, or Science City as a whole, which also was conceived as a type of information architecture. Then the structure, we're going to go a bit more into detail there. You see a little image of the so-called Exerptenschrank of Gottfried Wilhelm von Leibniz. He was a philosopher and a scientist, and had a huge amount of small notes and excerpts which he organized, and he was thinking a lot about how he can most efficiently organize these sort of things. And of course, if you want to organize, you have to put structure into things. So we have card boxes. Today, in the age of computers, we have databases, hypertext, structured text. If you think of XML, and then the semantic web, which is something like a vision for the future. Then the last type are interfaces. Here you see an image of office equipment of the early 20th century. Nowadays we probably more talk about graphical user interfaces, web browsers, also virtual reality, interactive facades, or visualization techniques. So to zoom these images a bit up here to give you an illustration of the Oechslin library in Einsiedeln, you're going to see that in early November. Also here, that's another example from that. These are 2 illustrations for space. A quote from that time, he, and then embraces mankind, which is interesting, has built a civilization so complex that he needs to mechanize his records more fully if he is to push his experiment to its local conclusion and not merely become bogged down partway by overtaking his limited memory. So he realized that there will be so much information eventually that we need to start collecting this information and organizing this information. He calls it to mechanize and record this information. And this was very visionary at that time, and we will see how that proceeds now. What came next then is that the card box was electrified, as we have seen already before with the birth of IBM. The punch cards played a very central role, and this was mostly due to the electrification, so moving from mechanical to electromechanical systems, and then later on to purely electric and digital systems. Around the same time, namely in 1951, there was one of the very important books that was being produced. It was by Maurice Wilker, David Wheeler, and Stanley Gill. Shortest book in computer science is always called the WWG book. It was one of the first books that gave instructions for computer programming. And very interesting in our context here is that they also invented the concept of subroutine libraries. That means computer programming libraries. And they have been using these libraries here on the image on the right-hand side. You see this cabinet. Basically, they kept the punch cards, which contained the library code in this cabinet. And in order to use these libraries, they had to copy from the punch card. They had this machine here to actually copy the codes onto the small tapes here, which in the beginning were also punched tapes and then eventually became like magnetic tapes. So they could copy library code and use them over and over again. So the concept of code reuse basically was born at that time, because they realized that software always contains bugs and errors, and if they can save the time and reuse their code, they can also reduce the number of bugs. Okay, another interesting man is this guy here. He's called Niklas Luhmann. He's a very well-known sociologist, or he was a very well-known sociologist and system theorist, who was mainly interested in the communication between humans. So he was interested in networks and not the humans per se. And in order to work in his way, he basically invented a paper-based hypertext. He called this the Zettelkasten, so he used this box, and in there he made cross-references from nodes to nodes. So it's like an early system of a cross-referencing system, but only on paper, and as you can imagine, probably not so convenient if you're looking for something. So back to the age of computing, of course, what eventually involved and what was a very important milestone is the dawn of the databases, which started around 1962. So in retrospective, of course, the database was the logical step from cards to computer, but that also means a lot of hardware development behind, a lot of evolution in terms of storage, of processing power, and so on. Today, most databases are organized in a relational manner. That means like an Excel sheet. So you have basically two coordinates to describe any position in a matrix of data containers. This can also be multidimensional, so it doesn't have to be two coordinates. It can also be a lot of more coordinates, and that's typically the case also. Today, databases play a very important role, maybe not very much on what we see on our front ends, but any server system in our data centers, or most server systems in our data center, are running databases because they are the fastest and the largest electronic containers that we have nowadays. Okay, maybe a bit more interesting than databases, because visible and very exciting is one of these very important milestones which was realized by Ivan Sutherland in 1963. He called it the sketchpad, and it's something that he realized as part of his PhD thesis, which is called Sketchpad, a man-machine graphical communication system. And he already had like CAD-style interaction types, so he could use the system as with a pencil to draw things. And so this system is accounted for as being one of the first computer graphics applications. Okay, then we have another example, which is by Ted Nelson. Ted Nelson is accounted for coining the term hypertext, but he was also among the first people who used the words hypermedia, transclusion, virtuality, and similar terms. So the main idea of his work was always that his basic viewpoint is that we should not simulate paper with our computers, that we should try to go beyond the way how we use paper. And of course, then one of the important things is that you try to cross-reference and to reference between two different papers and so on and so on. And he's also quite responsible for a lot of critique that we have in today's web systems, for instance, that we have only one-sided links, so it's always unidirectional, which results in a lot of lost links, of open links that are not connected anymore. Therefore, he founded a project, Xanadu, already in 1960, which had the goal to create computer and information networks with simple user interfaces. Unfortunately, the project was not so successful. It's still somewhere out there, but it has never really become very big. Okay, so if you go to the interface side, here you see the first computer mouse, which was invented by Douglas Engelbart. He patented this in 1970 as a XY position indicator. What is not true is very often the invention of the computer mouse is accounted to the Xerox PARC, but this is actually not true. So Douglas Engelbart was not working at Xerox PARC at this time. But as we shall see, there came a lot of important inventions from Xerox PARC. Then also ETH Zurich was involved in a couple of inventions, namely Niklaus Wirth, who designed the Pascal programming language in 1968 and came back from Xerox PARC in 1977 and could not take any hardware with him, so he started to create his own hardware here in Zurich, which was called the Lilith, which was completely written in also one of his languages, Modula 2, and included a graphical user interface, included databases, laser printer, connectivity, and so on and so on. Unfortunately, also this piece never really made it to commercial usability. I think they produced a number around 100 of these workstations for use with the students, but that's basically it. So maybe notable here is Wirth's law. You know, computer science has always a couple of laws. Niklaus Wirth once said, and I think this is very true, software is getting slower more rapidly than hardware is becoming faster. So that means if people who claim that all the hardware evolution that we have will eventually solve all our problems, there is in contrary Wirth's law that says, well, hardware might be getting better all the time, but the software is getting bigger and slower all the time, so you cannot win with just improving the hardware. So this is another very visionary example from Alan Key. You see on the left side, it's actually only the thing here on the left side, which is the Dynabook. Where is my mouse pointer? Ah, here. Okay. So this little thing here, Alan Key built at Xerox PARC, was the so-called Dynabook, and they started to think about that idea. It was more about the concept, because at that time the hardware, of course, was not that far advanced, but it was more an envisioning where we could get when all this hardware would become available. And at that time they could visit some labs where they saw like LCD flat panel displays, and then of course instantly imagined, okay, we would rapidly move towards tablet devices when we had all the storage and all the things that would be small enough to attach to such a display, right? So, and this is basically what has become reality now after so many years only. So if you look at this, it's almost 43 years ago. Yeah. And this is basically the computer that was built at Xerox PARC in 1970. So this was before ETH's Lilith, and this was the basis for Niklaus Wirth's Lilith. It was one of the first computers, or it was the first computer with a graphical user interface. It, as you can see, it contained a mouse, it contained some sort of scanner. Interestingly, also the display was turned around, so it could basically capture one page of letter-sized paper, right? And later on, all these concepts, of course, made it also into Apple, who started manufacturing these first computers for a larger audience and a larger public. So if we move back to software, there was something very interesting in the 1980s, in the late 1980s, which was called HyperCard. It was programmed by a guy called Bill Atkinson at Apple, and it was basically an early stage of the World Wide Web. It was a hypertext software where you could put in videos, audio, text, and you could all cross-reference and link things up. The only thing that you couldn't do at that time was there was no networking support yet, so all you had was just remaining on your machine. But in terms of, say, interaction comfort and all that, the system was pretty advanced, because in contrast to today's like HTML coding or whatever, here everything was totally graphic, so you would create the whole networks, your whole notebooks and widgets and all that in a graphical way, and it was quite convenient actually to use it. But then soon thereafter came quite a difficult time for Apple, and that's also how HyperCard disappeared and never made it really far in terms of distribution, because it was also never available on Microsoft Windows. Okay, soon thereafter, very important step, of course, came the World Wide Web, which was invented by Tim Berners-Lee. You can see here the desktop of one of on the computer where he developed the whole thing. It was around the next operating system on the next computer. It evolved from the 1980s at CERN, where Tim Berners-Lee worked, and he started being interested about, okay, how can I cross-reference all the different information sites here at CERN, because CERN already had a very large computer infrastructure, and on every server and computer there was information which would have been ready basically to be presented on networks. Yeah. So then already by 1990 the first versions of HTTP, HTML were defined, and there was also a corresponding web server which was info.cern.ch, and the browser at that time called World Wide Web was implemented. And from there you probably know the whole avalanche of the World Wide Web started to roll. There were new browsers, new standards, and we're moving towards what we have today. Yeah. So if we jump a little bit in time, there's some work from ETH Zurich in the early new millennium, where Maya Engeli and Gerhard Schmid was also involved in all these projects, started thinking about, okay, how could we start using these hypertext mechanisms for online collaboration, and they basically started creating projects and collaborations that would span around the globe. So you would have had architecture teams getting up in South Korea and started working on things, and then passing on the work to Zurich as Europe woke up in the morning, and then the work was further passed on to the US East Coast, and then the West Coast, and then back to Korea. So basically one started thinking, okay, what could we do with all these linked up networks? How are they possible to be used for collaboration? Of course, they were not the only ones. There's another example also from Switzerland, which leads more to the metaverse hype that we had some years ago, so virtual environments online. And as we shall see now, this has probably faded a little bit, but the newer things that came up after that is the so-called Web 2.0, which really is a very dramatic change, and possibly the most important change compared to the first version of the World Wide Web in the early 90s. So what is the difference of the Web 2.0? It's basically that it's the read and write web, right? So it's not just a passive function, but it's also something that you can contribute to. So the basic concepts there are basically that it's you have rich internet applications. It's not just a dumb page which passively displays the information. You have service-oriented architectures more in the background, basically that you focus on how can I provide different services to users. It's still a bit of a buzzword because, I mean, that's always been the case. And very important is that the whole Web 2.0 actually enables social collaboration in the internet. So, and that's why we are going into an overview of the social media. The social media refers to the use of electronic and internet tools for the purpose of sharing and discussing information and experiences with other human beings. I don't have to go into that. You probably know all the social platforms. You have photo sharing, video sharing, blogging, and so on and so on. What are the basic principles that the social media conversation follows? social media conversation was supposed to be. It's not hierarchically organized, no hierarchical control, and there's no central message. At least that's what it was supposed to be. But it was supposed to be vibrant, emergent, also fun, and compelling. So I leave it as a task for yourself what it is nowadays and what it's not, because I don't think this might be nice buzzwords here, but we know that the reality looks a bit different nowadays with all the privacy issues, advertisement, and so on and so on. So if you go back and look at how the web has evolved, basically we moved from a very static 1.0 version towards a very dynamic 2.0, and we're still in the process of this, right? So again, in terms of numbers, in 1996 we had like 250,000 mostly read-only sites and about 45 million users worldwide. In 2008 there are 80 million read-write sites and more than 1 billion users worldwide. And as you see, the collective, here on the green, is growing and growing. Yeah? So to put this face to face, the principles of old media, of course, is that you have a minority who writes for a publisher and who then sells to the majority as the publisher owns the production and distribution channels. What are the principles of the social media? Is that anyone can produce, copy, and share anything with anyone at almost no cost. So what do we mean by collaboration? We not just communicate and interact, but collaboration is a true community that follows a common goal. Okay, so we have one-to-one communication-centric. One-to-one content-centric means that there's a common goal already. One-to-many, same for content-centric. Many-to-many, and in the collaboration case again, a common goal. So if you look at the collaborative culture, we see we have like command and control. We have hierarchies, as you see on the left-hand side, while in a true collaborative manner, there's not so much hierarchy, it's more consensus-driven, it's more informal, it's also more a mentoring culture, and instead of having fear of making mistakes, it's also a trial and error culture. So let's have a look at the needs that the tools address. Today's tools help you to find and connect with other people, to share information, to share content with others, to communicate quickly and without a lot of overhead, and also cheap, to consume the relevant information from sources that you trust, and then you want to share any information you find with others as well. You want to communicate spontaneously and directly with others, and you want to contribute to and use collective intelligence. So there's a behavioral change to me 1.0 to me 2.0. So to summarize this very briefly, the trend in social media is the continuous shift to upload and share rich multimedia content in an accelerating movement towards participation. This represents a shift in media consumption and production from passivity to personal contribution and control. Will there be social architectural design, social urban planning? Okay, so I think time is advancing quite quickly now. We go quickly into the trend section, which is something about predictions, and this is probably something to laugh at. Prediction 1 is, I think there is a world market for maybe 5 computers. That was Thomas Watson, chairman of IBM, who stated that in 1943. Prediction 2. Computers in the future may weigh no more than 1.5 tons. That was in a popular mechanics magazine in 1949. 640 Ks of memory ought to be enough for anybody. Bill Gates. Although this one is not really confirmed, yeah. But I can imagine it's true that he said that. There is no reason anyone would want a computer in their home. Ken Olsen, President, Chairman and founder of Digital Equipment Corp, DEC, 1977. So, what we want to show with that is that at the moment I think we're still in a very, very big Web 2.0 movement, and it's been a very long-term vision that the whole internet would move towards a semantic web. Unfortunately, it has not become true so far, and while there are still a lot of examples and trials on the internet and you can use these sort of things, it's a great breakthrough is still not there. The main problem is that most of the information that is there on the internet is not understandable by the computer, and that means it's not processable by the computer. So the vision would be that we have a semantic web which contains information that is understandable by computers, so they can perform more of the tedious tasks involved in finding, sharing, combining, and information on the web. So the semantic web vision is not just about helping software become smarter, it is about providing new technologies that enable people, groups, organizations, and communities to be smarter. Will there be semantic, architectural, and urban design programs? Okay. I think we're going to stop here. I think the slides are accessible on the web too, so you can have a look at the last section as well. But I still, if you have some questions or points for discussion, I would be available now, yeah?
I would have a question about the Web 2.0. What is the main advance to the previous version? What is the main change that we would call?
Okay. I think I don't know how much you have experienced by your in your own life about the old web, the so-called old web. I mean the Web 2.0 arrived from today to tomorrow. So in my own experience, and long before the term Web 2.0 was coined, there was a visible change from very static content to dynamic content. I think that was one of the first most important things, that you visited a web page that would start to behave dynamic depending on what type of input you provided, what type of context you provided. Also, already soon you start to have a profile, so the web page basically started to react on your profile, and then eventually, of course, you could start to contribute. And I think this was one of the major breakthroughs when web pages started to accept contributions. Because originally the only thing you could do was just a dumb upload. You needed to use an upload tool and you could upload an image or something. And then I think, for instance, one of the first steps where you could go and edit the wiki page and just hit edit, you do something and you save, and it's there on the web and visible by millions of other people. I think that was the real breakthrough for the Web 2.0 and the real difference also. It all existed already, you know, in the first, maybe in the Web 1.0, but it was just not convenient enough.
Right, thank you.
Okay, any other questions?
Yeah, I got a question. You say that the semantic web is about the software getting smarter and the users getting smarter, but isn't it more important that the communication between the two gets better?
No, that's a good question. I don't think the software, well, smart is a difficult word, you know. I think that the users will never get smarter. I think they will either get dumber or they will stay as smart as they are. But I think it's a combination of of communication and organization. I think so far, we have in computer science there has been like people thinking about building ontologies like word spaces, meaning spaces, and all these sort of things for years. The problem is also again, I think it has not become practical yet. Basically providing metadata for any type of information has been around for years, right? But who is going to add metadata? You can probably use like crowdsourcing and things, but people are generally too lazy to add metadata. So, for instance, if you look at the picture library, I think people can still go and say, okay, this is Paris, but is this already smart enough or not? I don't think so. You need more. If you want to really annotate pictures and make them ready for being searched and all that, for instance, in this case, image recognition algorithms need to be way more intelligent, so they can do something like automatic tagging. And I really think to achieve a fully semantic web, we need way more powerful automatic methods. Whether we're going to have them in the near future is another question. Like computer vision and all these things have promised us already a long time that these algorithms will be available very soon, but so far it's maybe they work at 70%, 75%, and then you still have 25%, which is just garbage.
Okay, thanks.
Other questions?
And then how do you envision that for architecture or for urban design? What do you see that as the semantic development? I mean, then in reality, going from virtuality to real results.
Mm-hmm. Well, in real built architecture, I'm not sure if I can answer that question because I'm not an architect. I've been, as a software engineer, I've been creating tools for architects for a long time, and I think what could be useful or very useful if the tools get smarter in a sense that they can provide more context, that you create tools that capture the knowledge that capture architectural knowledge, and you don't have to start from scratch. So if you could say like the tool supports you in creating something, especially nowadays, that you not just have the architectural freedom in creating something, but say you have sustainability concerns, you have transportation context, you have energy, all these sort of things, and I think, for instance, tools like Arno Schlüter is also doing with his low exergy work that moves toward that direction, that the tools can support architects in an intelligent way by including semantics and context.
So that the software suggests better results and anticipating what we are trying to get.
Yeah, suggest is a good word. I think you can have the best tools and still do crappy work, of course, and you can have very bad tools and do great work. But I think tools should be there as assistants and as you say, make suggestions where possibly humans cannot detect things in a few seconds, right? So you can imagine doing very complex analysis in the background, simulations. You can do energy optimization or these sort of things all in the background, and then tell the user of the tool, okay, what you do here is probably not the smartest thing. You could consider changing this or so. But the design choices in the end will always be with the architect, right? Because I don't think architects will ever accept a computer that takes over the choice, and I don't think this should be the case either.
So architects are going to be the decision makers in the future, not the artists, but the decision makers. As for you.
Yeah, well, architects are already decision makers, right? It's, I don't know. It's a difficult question. You know, I know this very well from the digital arts. I've been involved in the digital arts, and we've been trying to create tools that support the artist in an intelligent way. And of course, there's always a big discussion. Well, how far are you willing to delegate certain decisions regarding style and design? And people are usually not willing to go very far there. But on the other hand, if we look at today's tools, you know, look at Rhino, for instance, how deeply this already influences the stylistic work of any architect. So we are all shaped by our tools. You know, the question is, do we understand that we are shaped, and do we understand in which way we are shaped by these tools, so we can take the necessary measures.
Okay, then I got a question about that. You think that the computer engineers or program writers will get a bigger role in the architecture in the future, or do you think that the architects will change as their tools change, and actually will get smarter as the tools get smarter? So do you think the architects will be shaped by their tools, or the tools by the architect? That makes sense.
To be honest, I hope not that computer scientists will get too much influence on the on the tool and on they create, and consequently on the architecture. I don't think this would be a good scenario. I think what is really required is that there are computer scientists and software engineers that try to really understand the way of how the architectural processes works, and vice versa, that architects are willing to jump into the sea of technology and also start to understanding how computer programs work and programming works, right? So I think in the end there's only this sort of multidisciplinary working together which can really result in successful future tools.
Is programming a basic skill of a future architect?
That's a good question. I think it depends a bit on the specialization. I think for certain architects it possibly should be one of the basic skills that an architect should understand. But of course, programming is not something you can just put into a flat bucket, right? Programming per se is very nuanced, and you can start with simple scripting tasks, some small scale programming. I don't think architects will have to be programming experts. I don't think that's necessary. But I think it's good to understand how your tools work, right? And one natural step towards that understanding is to know a bit about programming.
Okay, thanks.
All right.
Thank you, Stefan.
So I guess that's it. Thank you for your questions and for listening, and have a good afternoon in Zurich then.
Bye-bye. Thanks.